Check 1, 2. All right.
Okay, here we go. All right, let's get started. All right, well, hello everyone. My name is Cody Amour, and I'm going to be doing a live stream here just on my couch. So just to give you a few ground rules, please be sure to leave any of your math questions on the, should be on this side actually, in the live chat box over here. So that way I can respond to them and attend to every question. So I had a question last week that was pretty good actually. It was just they wanted me to talk about rings, and rings is one of my favorite topics. So we're actually going to start with that topic. What are rings? Now, before I get started, I just want to let everyone know there's a couple people watching. Just be sure if you got any friends on Facebook or on YouTube or whatever, just send out this link. The URL is actually up here. So just click on that and just share it and just say, hey guys, there's free math tutoring for anyone who wants it. We do this every Sunday and Thursday and at 9 p.m. Eastern time, which is actually right now. So about 1 minute ago, that's when it normally starts. So again, Thursday, Sunday, every Thursday, Sunday we do this. Well, I do this actually. So this is just my way of giving just some free tutoring to some students. I'm actually going to be starting my classes, my math classes, in about 2.5 weeks. So I'm going to have a lot of my own students here in this live stream pretty soon here, which will be pretty cool. So this live stream is definitely going to get more popular later on, but this is just kind of to establish this YouTube channel. Let me just give you a brief rundown of what this YouTube channel is while you guys are writing in the live chat over here. The purpose of Amour Learning, which is what you see right here, and with this YouTube channel, is to just provide free math learning, math education for everyone, and something that's kind of easy and personal, so that you're not scared by this creepy math professor. So, truth be told, I am a math professor at a university, and I started when I was 20 years old. But being a millennial, I'm more interested in how to teach math in a way that's just more fun, more easy to understand, more engaging too. So my goal is to get all of my students engaged in the learning, but also I want to make everything just really personal, so it's not too scary or anything like that. Most people hate math, to be honest, but the reason why you're here is probably because you need some help with math, to be honest. So let me help you with that. So again, if you haven't done so already, make sure you put your math questions on here. It could be silly, it could be easy, whatever you want. Doesn't matter. There's no stupid question here. So just post your math question and I'll answer them. Now, that being said, there was a question, like I said, last week regarding rings. The question was basically, what are rings? This is a very advanced math topic, so if you are a math major, then this might be a good question for you. But if you're not a math major, then this question is going to be rather difficult. So prep yourselves. Let me tell you what a ring is not in this context, because if you're not a math major, then let me just establish something real quick. This is not a ring. This is absolutely not a ring. That is definitely not a ring. That is not what we mean when we talk about rings. By this, I mean rings that hang on each other or anything like that. That is not rings. Rings are very, very, very different. It's actually an algebra thing. It's an algebra topic. So first of all, we got to figure out what algebra is. It's really important to understand the different, what's the word I'm looking for, topics in mathematics. So there's algebra. That's one topic. There's analysis and discrete math. So these three things are the main topics in mathematics, and they each have their own their subtopics within them. Now that being said, there's going to be a lot of mathematicians that are just instantly going to disagree with what I just wrote here, but to me this is just a simple, easy way of describing what the mathematics can be, how mathematics can be disjointified, if you will. So abstract algebra is one of the algebra topics. Algebra really talks about how does math interact with each other? How can we get math to interact? So if I have some things that I want to play with, how can I play with them? And what do I know about them? And can I think of something like a universe or something funky that works really cool? So for example, we're getting a little bit of delay. There we go. So for example, you can play with some integers. When you're a little kid, you play with numbers like 3 plus 5 and 7 plus 2, and you learn about this plus thing. And later on, you learn about this subtraction thing. Later on, you learn about multiplication. And those things are what's called operations. So let me write that down real quick, because that is absolutely relevant to this topic that we're going to be talking about today, which is rings. So we have addition, subtraction, multiplication, division. These are operations, and you could do these operations to a lot of things, like, for example, whole numbers. I can add 2 plus 3. I can add 5 plus negative 3. Well, that's not whole numbers. 5 plus 10. Those are examples of addition with whole numbers. But then later on in your middle school years, you learn about things called negative numbers. And negative integers are numbers that are like the opposite of whole numbers, and that's a totally different topic for another day. But if I have addition, I can play with addition with those integers as well. So negative numbers you can mix with whole numbers, and you can do stuff with those things with addition. So something like 5 plus negative 3. Oh, hey, I can do that. I can do 5 times negative 3. I can do 5 minus negative 3, and weird things happen in those. And so you enter this new universe. Now you have these negative numbers, and you can do all these things with them. There are some things, though, that you can't do these 4 things with. For example, matrices. If you've ever taken a linear algebra course, if you're an engineer, you're going to need to know what these things are. I'll give you an example of a matrix. So here's an example of a matrix. It's got weird brackets and the number 2 and 3. This is a matrix. It turns out that you can do some matrix multiplication. Sometimes. Sometimes you can't. And division is something that is really fishy, where things get really kind of crazy. Sometimes you can do division, sometimes you can't. And so addition, sometimes you can do, sometimes you can't. If you're in a Calculus 3 class and you haven't taken linear algebra yet, or some sort of vector calculus class, vectors, you can add vectors, you can subtract vectors, but you can't really multiply vectors unless you're doing some sort of cross product. But what is the cross product? How does that work? That's an operation, and that's a weird, funky operation where you do some strange things and you get this new vector. Division, how do you divide vectors? That's a very strange concept to think about. So you have all these operations, and as you progress in your mathematics, you find that these 4 operations you can't really do. Well, some of them you can do, some of them you can't, and there's special cases for them. So it's important to understand that there are a bunch of operations, and some of them you can do stuff with, some of them you can't. Now, it's also really important to understand that abstract algebra is pretty much all about these operations. So how do they work? When do they work? Why do they work? If they work, how do they work? And if they work in certain ways, what does that mean? That's basically all of algebra in a nutshell. Now, that being said, let's talk about rings. Rings are very, very cool. Specific rings are even cooler, but let me talk about rings real quick. So rings, you have basically 2 operations. You have the plus and you have the multiplication. Now, with these things, you can actually develop things like subtraction and division, If you want to think about subtraction, it's really just adding the opposite of something. If I want to do, for example, 5 minus 3. Well, minus is really the same thing as addition, but let me change it into an addition problem. This is actually the same thing as taking 5 and adding the opposite of 3. That's 5 plus negative 3. So in this way, you can, you can have some, cool. You can take an operation like subtraction and turn it into addition. Division, you can actually do the same thing with. Let's say I wanted to do 5 divided by 3. Well, you can do this with multiplication. You can actually turn the division into multiplication. Oh, that's kind of hard to see. Let me try to fix that. There we go. If I want to do 5 divided by 3, I can actually just do 5 times the inverse of 3, which is 1/3. So that's actually, these two are the same things, it turns out. So it turns out that if you have plus and addition, then you really have all 4 operations, kind of. Sometimes, not always. We'll see about that. But basically, a ring is a place where you can do these two things. That place, actually, we're going to give a name to it. It's going to be called R. So let me talk about R. R is a set of objects. It could be a bunch of things. Normally, typically, it's like some sort of number system, like whole numbers, for example, or just the prime numbers, or even numbers, odd numbers, negative numbers, positive and negative numbers, matrices, vectors in the third dimension. There's a lot of different things you can make R, but particularly we're going to want a set R where we can do these two things. We can add stuff and we can multiply stuff. Now, let me talk about, there's some certain rules that we need to follow in this set of objects. We have all these things like whole numbers, for example. Can we add whole numbers? Yeah, we can. Can we multiply whole numbers? Yeah, we can. But what's important is when we talk about this thing, it's really important, these two things, either these two things, it's really important that it actually works and we can stay in this universe. So this is like a universe that we're going to be working with, a mathematical universe, if you will. And when we do these two things, we want to stay in the universe. So if you want to think about it in analogous to space, if I do certain things, I want to be able to stay in space. If I do something in space, if I make an action in space, am I going to fly out of the universe? If the answer is yes, then things kind of get weird in that scenario. So in math, we kind of like to, whenever we set our universe, we like to stay in that universe. That's a very important rule. Now, let me go through all the rules about these three things specifically. And this is what a ring is. So we have R, we have this plus, we have this multiplication thing. But here are the 8 rules that we need to follow. First rule is that if I have any 2 elements in my universe, then I can add them and stay in the universe. So if A is in R and B is in R, then A plus B is also in R. Now, I know we got a couple of viewers. I just want to mention and remind everyone that if you have any math questions that you want me to discuss, like what is infinity, what is 0, how can we play with these things? These are really cool questions. Make sure you enter in the live chat over here, and I will answer all of your questions. So be sure to read this thing that's scrolling up here. Post your questions in the comment section or the live chat. Let me make sure we don't have any comments. I don't think we do, but that's okay. Let me double check, and then we'll get back to this rule here. Well, while this is loading, let me explain again what this means. This thing right here is an element of. It literally means an element of. Let me do something real quick. Mute that. Looks like we don't have any comments yet. That's okay. just be sure to enter in your comments when you have a math question. All right, let me real quick go back to the settings. Okay, so this literally means an element of. So if I have this a is like a variable, but in a more advanced, a mathematically advanced way. It's actually, I should say, it's a constant. It doesn't change. So if I have just anything, and I'm not going to say it's a number because it might not be a number. It might be a matrix. It might be a unicorn. I don't know what it is, but whatever that thing is, if that thing is inside my universe, and I got another thing that's inside my universe, could be the same thing, I don't know, then if I do this operation plus, that result, that a plus b, better also be in my universe. So for example, subtraction won't work if I'm working in the universe of whole numbers. So subtraction can't be my plus symbol. It's not possible. Let me explain why. If I take 3 minus 5, I'm no longer in the whole numbers realm. That's not a thing anymore. We got a problem here because now I'm outside of the universe. I'm in -2. -2 is not a whole number. So I don't want to just pop out of the universe using this plus symbol thing. So the subtraction can't be a plus symbol. It can't be a plus symbol in the sense of rings. So subtractions, weird things happen when we make that a plus symbol. Now, we'll talk about plus symbols later on, but for now, let's stick to this. We'll come back to this rule later. The second rule is, I believe it's associativity. So basically, the second rule is it doesn't matter which order you add things. So if I have a plus b plus c, it's important to understand that I can add these three objects either way. I can focus on either addition in either order. So we use parentheses to tell people this is what I want to add first. So if I want to add these two things and then add c, it's the same thing as adding b plus c and then adding a. So you could do that in either order. These two things are equal. The third rule is also pretty well known amongst, supposedly, amongst high school math people, but it doesn't matter which order you add things. If I have a plus b, it's the same thing as b plus a. So 5 plus 3 is the same thing as 3 plus 5. 8 plus 7 is the same thing as 7 plus 8. It doesn't really matter which way order I throw addition. So that means I can move things around pretty much all over the place. Plus, adding, it can be done in any order you want. The next thing that's really important is, let's see if I have any tissues. I don't. The 0. There is this weird special number called 0. It's actually, well, it's not really a number, it's an object. It's an object in your R. So every ring has the special number 0. So now, what is a 0? 0 by definition is just the thing that if you add anything to it, nothing happens. So basically, this fourth rule states that if 0, there is a 0, which means that 0 plus any number a is always equal to a. It's always true. There's a special number 0. So by definition, 0 is just you add it to anything, nothing happens. So let's talk about this in the context of stuff that you're familiar with. The integers, there is the number 0. If I do 5 plus 0, it's 5. If I do 8 plus 0, it's 8. Nothing happens if I add 0. But let's go into other weird universes like vectors. If you add there's this thing called the 0 vector that if you add the 0 vector, then nothing happens. Your vector doesn't move anywhere. It's the 0 vector, so nothing happens. So that's important to understand that 0 by definition just means that if you add it to anything, nothing happens. And there's some funky universes where 0, it looks a lot different than what you would imagine it looks like. So the next one is kind of an interesting rule. This is where things become more algebraic, if you will. This is where algebra comes in. Basically, the idea is every single every single object in your ring has an additive inverse, meaning that you can negate it. You can add something to it to come back to 0. So basically, a plus x equals 0 has a solution. There we go. So the idea is if you throw me any number, I can put that number here and I can solve this equation. So you give me the number 5. Can I solve 5 plus x equals 0? Yeah, x equals -5. Now here's the important thing. This is where the whole numbers kind of breaks down. The whole numbers is actually, along with plus and multiplication, is not a ring, because 5 plus x equals 0 does not have a solution. -5 is not in the universe. You've got to make sure that this is in R. That's really important to understand, that x is actually in R. Again, it looks like I have a couple more viewers. If you have any math questions, just please post them in this live chat over here, and I will literally address them right now. So, and ask any math question, and I will address every single one. This is just free math tutoring. So, also be sure to subscribe, and be sure to like this video so that more people can see it. Share it on Facebook, share it on YouTube, whatever you want to do. Share it on Twitter or whatever social media you use. So that's how addition has to work. So let's talk about the couple things of addition. Let's remind each other what addition is. Basically, you can add in whatever order, and there's this special number 0 where you can like add 0 to anything and nothing happens, and every single number has an additive inverse. So if you give me a number like 5, then I can give you like -5. That's the additive inverse to 5. If you give me 2, I can give you -2. And if I add those two objects together, I get 0. So this basically, this algebra problem has a solution. It actually can be done. Now let's move on to the last 3 rules. Rule 6 is basically multiplication. Basically says I can multiply and stay in my universe. So if A is in R and B is in R, then A times B is in R. So this basically is establishing that the multiplication works. Like if I multiply 2 things, I'm not going to fly out of the universe. So let me give you an example. The whole numbers, it doesn't work. Actually, sorry. I'm thinking of a different thing. So whole numbers, 2 times 5 is 10. Hey, I didn't fly out of the universe and become a matrix or a vector or something. You know, nothing crazy happened there. 10 is a whole number. You give me any 2 whole numbers, if I multiply them, I'm gonna get a whole number. Let's talk about, let's see here, the second to last rule and the last rule. These last 2 are basically establishing rules with multiplication. The first one is the associative property for multiplication. So basically this says that it doesn't matter what order I multiply things. So if I have A times B and then times C, this is the same thing as B times C and then times A. Doesn't matter which order I multiply 3 numbers. So that has to be absolutely true. Last rule is the distributive property. So if I have A times B plus C, this is where I'm mixing the operations. How do I do this? Which one do I do first? What's going on here? Well, this has to be the same thing as doing A times B plus a times c. There's also, if I flip this over here, then these two would be flipped as well. But this is kind of the most, I'll say the other thing also, and b plus c times a equals b times a plus c times a. So those are the two different ways of saying the distributive property. Hey, I got more viewers. So again, if anyone has any math questions at all, please be sure to post on the live chat. I do want to mention to those who are viewing, we do this every Sunday and Thursday at 9 p.m. Eastern Standard Time, which was about 25 minutes ago. It started 25 minutes ago. And this is just kind of free math tutoring for everyone. So right now we're talking about rings because someone asked last week about rings. And it's a cool math topic. So I'm just finishing up on this, and then we'll get to some more questions in the comment section and or this live chat here, which is kind of dead right now. That's fine. No problem. Once my students come in, then things will get kind of crazy. Now, let's talk about some more properties. This is actually all that you need to establish what a ring is. Real quick, let me check the comment section, see if we got any commenters. Let's see here. Got 5 people watching. That's good. I need to quickly go to YouTube, and then I will address any questions. Again, if anyone has any questions at all, live chat over here, and I will address all those questions. Also, if you wanna subscribe to my channel, and you'll get these pop-ups every week at Thursday and Sunday, and that you'll be able to see where the free tutoring is. You could do so. All right, so. Doesn't look like we have any comments yet. Nope, no comments. That's okay. Let me fix this. All right. So, we have 6 viewers. That's awesome, guys. Make sure you share on Facebook. Make sure you share on YouTube. And make sure you ask your questions on the live chat over here. So. Alrighty, let's talk about special rings. Rings right here that we've talked about so far, they're pretty much kind of boring. There's nothing very special about them. When we start adding some properties, really cool things happen. So for example, commutative rings. Pretty much everyone works with commutative rings. Anyone working with rings that are not commutative are basically doing what's called, I think it's called abstract nonsense, which is basically a math field which deals with mathematical objects that no one really understands or cares about other than people studying abstract nonsense. So commutative rings, basically multiplication is commutative. Ring with an identity. So sometimes a lot of people throw in the ring with identity. This is a really, really cool object. But it's called the identity. If you've ever done linear algebra or anything like that, it's often called the identity matrix. With people who are in elementary school or whatever, it's called 1. That's literally what it is. And it's pretty much 1 until you get into calculus 3 or elementary linear algebra. So let's throw in the number 1. The number 1 is very special with multiplication. Addition, 1 actually does something. 5 plus 1 is 6. That's actually a new thing. But multiplication, 1 is a special number. Specifically, the idea is if I multiply by 1, nothing happens. And it actually also doesn't matter which side I multiply this on. However, we mostly deal with commutative rings, so I'm just going to leave this as it is. Basically, 1 is that special cool number where if you multiply by 1, nothing happens. So 1 is like the identity to multiplication, whereas 0 is like the identity to addition. So rings with identities are very, very cool. But now we're going to get into some very, very, very interesting stuff. Integral domains. This is where things get pretty fancy. So if you want to add a new rule to rings and make it an integral domain, basically the idea is if I multiply any two numbers and I get 0, that means either A is 0 or B equals 0. Now there are things that are literally not integral domains. Matrices, there's some examples to this. If you work with modular arithmetic, there's some pretty interesting things. Like for example, if I wanted to solve 2x equals 0, but we're working mod 6. If you don't know what this is, that's okay. Don't worry about it. If you're computer science or anything like that, this is kind of cool. This has a solution, but the solution is not the number 0. So we're actually not working in an integral domain here because the solution could be 3, the number 3. There's 6 objects in mod 6, 0, 1, 2, 3, 4, 5, and 6. If you don't know anything about mod 6, just ignore what I'm saying right now because it's kind of fancy, but the idea is in mod 6, it's not an integral domain because the solution to this could be 0 or 3. Turns out that 2 times 3 is 6, which is 0 in mod 6 world. Anything divisible by 6 is 0 in mod 6 world. So 6 is divisible by 6, so by definition it is 0 again. So 3 is a solution to this, which is a problem. So this is not an integral domain. Most things are. If I am working over the real numbers and I have something like this, and I'm solving for x, basically there are 2 possible solutions. X could be 1 or x could be 2. But one of those has to be true. They can't both be not true or else I would have a problem. So it turns out that the number system, the typical number system that you work with in high school, middle school, elementary school, is in fact an integral domain. And the last thing, this is where I think this is, yeah, the last rule that we can throw in there that makes things really super cool is field, rule number 12. So rule number 12 basically says that that you can do division, basically. That a times x equals 1. There is a solution to this. So you give me any number and I can find a multiplicative solution. This is where the whole numbers is not a field. One of the reasons is because if you give me a number like 5, I can't give you a solution 5x equals 1. That doesn't have a solution. You might be saying, wait a minute, I could put x equals 1/5 there. But 1/5 is outside the universe of whole numbers. If we're working with whole numbers, 1/5 is not a thing. It doesn't exist. So it's important to understand that this 5x equals 1 does not have a solution in the whole numbers universe. So that being said, that is fields, and fields you can do pretty much everything with. Fields are really, really super cool, and there are a lot of different fields. So I recommend you looking into that. We will actually be posting an abstract algebra course within the next couple years, 1 or 2 years. So be on the lookout for that, and you can take that free course on our website, amourlearning.org. You can also, please be sure to subscribe to this YouTube channel. If you are not watching it live, that's perfectly fine. Hey, you learned something about rings today. That's awesome. And other than that, also be sure to follow us on Facebook. And please know that we are offering free tutoring every single Sunday and Thursday at 9 p.m. Eastern Standard Time, which was about 33 minutes ago. Most of the time, they're probably going to be 30 minutes, but once when my classes start and I have somewhere around 150 to 200 students, this YouTube live chat will become a little bit more intense. So please be sure to check us out every Thursday and Sunday. And we're also going to be posting some math courses pretty soon here, which is pretty cool. Within the next 2.5 weeks, we will post a statistics course, which is also known as a liberal arts math course. That will be posted in our YouTube channel, so be sure to take a look at that as well. And that being said, I'm going to end this live stream with that. So take care.